Thank you for joining us for another ASTQB webinar. Today we'll be talking about framework architecture for test automation. Frameworks for test automation are similar regardless of which automation tool you use. So this webinar will address common questions including why build a framework? What benefit does a framework provide? And how does one maintain a framework? We will explore different approaches to framework development and the various things to watch out for. This webinar is based on practical project experience, as you'll discover from our presenter, Andrew Polner, and you'll leave with a much better understanding of automated frameworks and the confidence to build your own. As I mentioned, our speaker today is Andrew Polner, who is President and CEO of ALP International Corporation, a leading organization in the area of test process improvement and in the use of test automation tools to bring efficiency and effectiveness to the testing process since 1993. Andrew is a director of ASTQB and sits on the executive committee. Andrew is also the chair of the Advanced Level Test Automation Engineer Working Party for ISTQB, the International Software Testing Qualifications Board. So as you can tell, Andrew brings a great depth of experience to test automation engineering, and we're really excited to have him today. Andrew, go ahead and take it away.
Thank you, Dave. Andrew Polner here. Thank you all for joining. Good afternoon, or good morning, or good evening, depending on where you're joining us from. Want to talk to you about why we're here today. We're here to talk about test automation and frameworks specifically. And with that, I'd like to share a little bit about my background in terms of how I got involved in automated frameworks, some of the baggage that we all bring to the table here from our experiences or maybe lack of experiences, and some of the expectations that we have as to what automation frameworks can do for us, or what maybe our management thinks the automated frameworks can do for us. So let's start with a quote: "Necessity is the mother of invention." Now, what does that really mean? Well, what that means is that when you're really put in a situation where you need to get something done, you tend to get very creative. And to put things in context, I got involved in automated framework development back in 1993. Yes, believe it or not, there were testing tools back then too. They weren't quite as sophisticated, didn't have quite all the features that they have now, but there certainly were some tools back then for people to use. So how did I get involved in framework development? Well, it was one specific project that I remember where we were hired in to assist an international organization in migrating their financial system from their current system to a new system. And I was put in charge of helping to test that effort. And because I was the sole tester, I had to find ways to make the testing process efficient and effective. So I thought about automation. Now, automation had already been around, so that in and of itself wasn't the solution. The problem was that I did not have the domain expertise. I did not have the knowledge of the financial system that we were testing. So I could not add any value in terms of figuring out what to test and what was working and what was not working when comparing the current system to the new system. But part of the group included financial analysts and business analysts, and they all understood that very well. But they had no knowledge of testing practices and even less of automation. So what I found was that if I could have them structure the information that they needed testing in terms of the data, the input data, the expected results, if I could have them structure in a way that was simple for them to structure, I could then write something using the automation solution of the time to essentially read those inputs, navigate through the application, exercise those controls, and validate the output data that they had provided. And believe it or not, that turned out to be a phenomenal approach for this project. It made it very successful. It allowed us to test very quickly. And most importantly, it allowed multiple people to be involved in the effort. So as a result of that project, I really started thinking that building a framework of that type to really get the benefit of the non-technical user, the business analyst, the functional tester, and also combine it with some good technology to actually drive the application seemed like a way to go. And since that time, believe it or not, it has been kind of an integral part of our standard consulting solution offerings that we do. Now, when you think about automation in general, there's a whole lifespan to automation. In the early years, when people start with automation, there's this initial euphoria. You've finally gotten the approval to get the tools. Some of them are very expensive, so you're pretty excited about that. Then you actually get the tool, you install it, you start reading through the documentation. You realize that there could be hundreds, if not thousands, of pages describing features and functions, and there's no real roadmap that tells you what to do, how to use it, how to best apply that tool to your particular environment. So then you become frustrated. When you try what should be something simple to do, all of a sudden it's not doing it. What the vendor may have shown you in a record and replay demo all of a sudden doesn't work so easily when you try the same against your own application as it did when you had the tool demonstrated. Now, the middle years of automation are when all the scripts that you've been developing all of a sudden start to fail. Now, the problem with that is that the test team is depending on you to run these scripts because that's how you're validating your application functionality. So if the scripts that you have are not reliable, then the whole testing effort slows down. And the whole concept of being able to run tests overnight, let alone over the weekend while you're off to the beach, just doesn't happen anymore. So that can be very frustrating. Also, as you start developing more and more scripts, most applications, let's face it, of even a medium complexity, will have several hundred scripts, maybe even into 1,000 test scripts that you need to run. So to automate those, when you start with a few dozen to a few hundred to a few thousand, you're adding a lot of complexity. And that complexity can then start coming back to haunt you if you haven't developed a structured approach to automation. And you don't want the scripts that you develop to actually be as complex as the application that you're testing. That kind of defeats the purpose. Now, in the late years, you're working as hard as you can to try to finish up the automation so that you can actually do a regression run and report on that. And then all of a sudden, you find out that the application was released already. Clearly, the effort that you were doing wasn't that important, or it took too long to get the scripts all working again. So that becomes very frustrating, and you even wonder if anybody cares anymore. So what do? Lacking the motivation to continue, you look for other projects, you find some web development, and you leave the testing team. And then the question becomes, did anybody even notice that there's no automation anymore? Now, this story is really something that happens more often than not because of the types of architectures that people choose to use or not to use, and a number of other things that we'll be discussing here. So let's go to another very famous line. What's in a name? That which we call a rose by any other name would smell as sweet. Of course, famous quote from William Shakespeare, Romeo and Juliet. Now, what's interesting about this quote is the name part. And when we talk about test automation, we really need to think about what these names mean and what the terminology means. And is it really automation or is it testing? And what's the difference? And what really is a framework? And when we're talking about roles, what roles do we need to have? And then what types of frameworks are there? And what are the differences? So if we define automation, automation in and of itself is the mechanization of steps. Now you ask yourself, is this testing? clearly it is not. There's many things that you can automate. You can automate the creation of user accounts. You can automate the deletion of report files from a directory. Those aren't necessarily tests, they're just automation activities. So we need to really think clearly about the fact that automation in and of itself is not testing. However, we can use automation to do testing. Now, talking about terminology, framework. What is a framework? Is it a script or a set of scripts? Is it a group of utilities? Or is it a toolkit? Maybe a framework is an architecture, a certain defined structure and architecture. Or does a framework define certain functions? Or maybe a combination of function libraries. What is a framework? Well, if we were to look up the definition of a framework in the dictionary, we have an essential supporting structure of an object or a basic structure underlying a system. Now, even though this is not the definition of a test automation framework, it is a really good general definition of a framework, because when we're talking about an essential supporting structure, that's exactly what we're talking about when we're talking about building automated frameworks. We're talking about something that is an underlying structure that's immovable, that's robust, and that leads us to automation from now till the future when we need to continue to use automation. Now, there's several types of automated frameworks out there, families of techniques that are used for developing automated frameworks. And I'm going to go over three of them. So we have data-driven, we have keyword-driven, and we have process-driven. Now, in the first example with data-driven, that's actually the least complex to implement. Why? Because it combines elements of static scripting and dynamic values. Because of that, anything that's usually easy to do up front typically becomes harder to maintain on the back end. So in terms of maintenance, the requirement we would say is high. Now, let's look at an example of a script. So on the left, we have the original script that sets the control to a main screen window, selects a menu item, sets the control to screen 1, then to screen 1A, and then edit sets or essentially populates the client number field with a value 1234 and the order number field with a value A1B4. Now, what we need to do to generalize a script like that is to look for those hard-coded values from when we originally recorded that script and create variables for those. So that's what we're doing on the right side of the screen. We're basically replacing each of the actual physical values with a variable. In doing so, what that allows us to do is create a table of values similar to what you see here, where we have 7 test cases, and for each test case, we have a pair of customer number and order numbers. And by exercising each one of these 7 different customer profiles and different order numbers, we're able to now reuse that same script 7 times over with different conditions with the hopes of identifying any defects in our application. So there is value in this technique. It's a simple technique, and then that has some implications with it. Number one, we are able to reuse existing test path for the script, as we've shown you. And we've substituted those values. And if we need to create additional data sets, it's easy to do that as well, because we're able to just add additional sets of data to our spreadsheet and then just run them through the same script. The data changes themselves do not require the script change because the script already has a predefined path. When we look at keyword-driven scripts are very different because they are very much like what a business user or functional tester would think of. For example, if we have an application where we're buying and selling stocks, we would want to define what we're buying, what we're selling, the quantity, and the price. So in a keyword-driven script, what we do is we basically set the actions that we're buying and selling, what the security is, at what quantity, and for what price. Now, what's nice about this is that when you look at this, it's very easy to read and understand because it's basically different conditions that a business user using that application would typically use in invoking the application. It doesn't have a lot of the details as to what screen you go to, what buttons you push, etc. Now, in a keyword-driven script, we have this buy-sell script. We set control to the main screen. We go to a file and select the action. And of course, what I'm showing in the red are the variables. So the action could be a buy or it could be a sell. We go to an action window screen, and then based on the data that was provided in the table, we populate the stock ticker symbol, the quantity, and the price based on the buy or the sell. So you'll notice that this is a little different from what we did previously because there's more information behind the scenes as to what we are trying to do, and there's less information up front, but it's easier to read through the keyword-driven profile. Now with keyword-driven, we have a script of medium complexity. There's a high degree of encapsulation, and it's easy for tests to be developed because all you need to do is specify in this example what your securities are, what you're buying, what you're selling, etc. Now, how about maintaining a script that's developed using the keyword methodology? Well, that is medium to high effort. And the reason why is because even though it's nice to have a simple front end with the keywords, what that means is that there's a lot of logic, and by logic I'm talking about application logic, how to get around that application, what things need to happen, how you go from one point to another, and all that needs to be pre-coded on the back end. And as long as those keywords are there and the keywords can drive that, you're in good shape. But there is a significant amount of effort in maintenance. And finally, from an auditability standpoint, we say that's low. And why is that low? Because when you specify your keywords, which are essentially the actions and what you expect done, you don't really know what is happening from that specification to the actual running of the script to the actual reporting of the script. So there is potential that you are doing something that you've defined in the keywords that's not being interpreted by the script on the back end, and you're getting false reporting. Or there's a possibility that something is being added to what you're doing that was not part of your keyword-driven script, but it was part of the code. So because of those reasons, we do have some things that we need to be careful for. Now, the third example that we'd like to talk about is the process-driven script. Now, in this case, we have something that's maybe almost a slight combination of the two. With a process-driven script, we define the process of what we are doing. And that process can be summarized in as little as 4 columns. We have a window column or a screen, an object or a control, the mode or the method, and the data. So if we look at the example here, we'll see that from the first window that we have defined, which is the login window, the first thing that we do is we go to the name object. And in the name object, what are we doing? There's an I. In this case, I stands for input. And the data that we want to input is auto. Auto is the name of our user, so we want to input his name. Now, the next step down is password. Password is also an object, and we use an input mode to input the password. And finally, we have, as we always have on our login screens, an OK button. So the OK is a button, is an object, and we use I as an input mechanism. And then the line below is saying, okay, let's go back to that login window, And let's see if the name field is in focus. Now, what does that mean to be in focus? Well, you know how when you go to your different applications, if it's a banking application or some application that requires you to enter your credentials, normally you expect that when you go to that website, that cursor, that I-beam, is going to be placed right into the name field so you can just start typing your username. But as we've all seen, there are some websites you just start typing and you're not typing anywhere because whoever built that website forgot to make sure that that I-beam should always be in focus on that name field when that first page gets presented. So this would allow us to test that the name field, that the attribute, the focus attribute for the name field is on. So you see how using the same notation of 4 columns, we can not only enter data, we can validate data, we can also check for attributes and a host of other things. Now, the process-driven framework is the most complex to implement. At the same time, it's the most flexible. And the reason why is because when you develop something like a process-driven framework, what you're doing is you're abstracting everything. And abstraction is basically saying to remove any reference to the application from your code, from your automation code, and move that all to your data. So in the example that I just showed, you would essentially create automated scripts in that type of format, and the code that would read that automation would not have any knowledge about the application, the object names, or anything else, because it's getting all that information directly from your test script. So in doing that, you end up creating a script that's very generic and very reusable and totally driven by the data on the front end. From a maintenance standpoint, because we have such incredibly reusable functions on the back end, there's low requirement for maintenance. And from an auditability standpoint, it's very high because every step of what you did in that script, from inputting to validating attributes to synchronizing to anything else you might want to do, all of that has to be defined in your test case because the code itself is not going to inject any of that information that's not already in there. Now, if we were to look at the different frameworks, we'd find that there's characteristics of each of them, and they're not all, rated in the same way. Some frameworks rate highly in certain areas and some in other areas. So for instance, we have characteristics of adding variations to existing scripts. So the level of effort for all of them is low. Then we have adapting to changes in application flow. Now with data-driven, it's medium. With keyword-driven, it can be medium to high. And with process-driven, because of its abstraction, it's low. And down the line. So we have a number of different categories: ease of code updates, impact of code updates, level of abstraction, complexity. Of course, data-driven is very low, keyword-driven, medium, and then the process-driven is very high. So again, there's not necessarily one right answer for everybody. And then finally, the degree of flexibility that each framework will provide for you. Now let's talk a little bit more about attributes that frameworks need to have. So the first and foremost attribute of a framework is, of course, flexibility. And that flexibility can be manifest in multiple ways. Number one, there has to be adaptability to the applications that you're trying to automate. You need to make sure that you build a framework and use the right tools that will actually work with the technology that you're using. It may be a great product, but if it doesn't support your technology, it really doesn't help you. Maintainability. The framework needs to be easily maintained because many times, especially when we're in an agile methodology and going from sprint to sprint, we don't have a lot of time to be making updates to our automation. So the ability to maintain that framework easily and quickly is very important. Reusability. You don't want to have to every time you're going to do testing, create new functionality. You should be able to initially spend some amount of time investing in the functionality, the generalized functions that you're creating for the different kinds of objects and controls that your application has, and then you should be able to reuse that from one release to the other. It doesn't matter if a new screen gets added to your application, as long as those controls are all the same controls that you've been using against other screens, you already should have the functionality to interact with those. And then scalability. It's one thing to automate scripts in the tens, 50s, or hundreds. It's a whole other thing to be able to automate in the thousands and to build something that's going to be robust, that's going to allow you to increase your amount of testing, to manage that testing, to know whether, when you have errors, if those errors are coming from the automation itself, or if they're application errors, or if they're environment errors. Having all the necessary things to do that is very important. And finally, extensibility. Every year, new technology comes out or updates to existing technology come out. We need to make sure that the automated framework that we build gives us the opportunity to extend the capability of that framework to support new technologies, maybe new controls. Maybe now you're using a calendar widget, whereas before you just had a field that people put a date in. You need to make sure that your framework and supporting tools support those particular widgets or other controls that you come up with. Form follows function. Another famous quote from years past referring to the modernist architecture and design. So form follows function is very important. And what that really means is that you have to have a function to what you're doing to be able to then define how your automation is going to work. Now, many of you have probably seen the announcements from last year with the release of the ASTQB Advanced Level Test Automation Engineer Syllabus. That is a labor of love that I've been involved with for many, many years. For those of you who have tracked it for a while, it was originally came out as an expert level syllabus, and then it was realized that it made more sense to reposition that at the advanced level. So that document was reworked. It has since been released at the advanced level, Test Automation Engineer. That document, the syllabus, and glossary terms for that document and sample exams are all available on the ASTQB.org site. So I encourage all of you to download that document. And a number of the training providers are also working on materials for training against the Test Automation Engineer syllabus certification. This diagram that I'm showing you here comes out of Chapter 3 of the syllabus, and it's just a wonderful diagram that basically describes so many things at once. So on the very top, we see project management and the test automation box. And we see on your left the configuration management, which is a very necessary component to all the artifacts that you use in automation, as well as test management over on the right. Now, if we look at the center stack, we see that test automation starts with test generation layer, your manual design and your test models. What is it that we're testing and how do we define that? We follow that with a test definition layer where we define the actual conditions, go down to the test cases and the procedures. And really critical for automation is the next band of test data that covers all three of those, and the test library where we have all that information available to us as we're using automated testing tools. The next box is the test execution layer, and that's really where we're talking about the different test tools, essentially what's driving the automation, the execution of the tests themselves. And below that, we have the test reporting, as you might expect, whether or not the test passed or failed, and if it failed, what part of the application did it fail in. but just as importantly, the test logging function of figuring out exactly what happened as that test ran, because sometimes there's other things that happen that are beyond just the reporting of that functionality that we need to know about, and we need to be able to make sure that the automation itself ran properly and that it reported properly on the functionality of the application. And then below that, we have the test adaptation layer. Depending on what kinds of tests we're doing, we need to interface to those environments. So if we're doing user interface tests, we need to be able to have a layer that adapts to the GUI, the graphical user interface. Or we may be doing testing around API or services, or maybe protocol-based testing or direct connectivity to different databases. So there's a lot of different components to what our automation needs to have to work properly. Now, as is the case with other ASTQB and ISTQB syllabi, the test automation engineer syllabi is not a how to create automation with tool A, B, or C. It's actually tool agnostic. It's purposely written in such a way that it should apply to multiple tools that organizations are considering. We're not trying to play any kind of favoritism with one set of tools or another, but rather we want to give common best practices and definitions of what automation needs to include in terms of components and functionality and the importance of that. Now let's talk about the essence of functionality in a framework. And if you don't remember anything else from this talk, I'd like for you to remember this, because this is the key to building a successful automated framework. You need to remember these four terms: input, navigate, synchronize, and validate. Now, what are we talking about here? Well, if we go to input, we're talking about when you enter or select information from an application control. So that could be an edit field where you enter your name, you enter a date, what have you. Or it could be a drop-down list where you're able to select something. It could be a link that you click on, or it could be a calendar widget that you select a date from. So these are just a few examples of the things that you do when you do an input function against your application. And the reason why we're talking about that is because this is one of the four essential elements that framework functionality needs to have. Navigation. So navigation is basically, how do we get from point A to point B in our application? Now, some applications, you can do that with mouse clicks. Sometimes you'll have the ability to use keyboard shortcuts. Other times, you'll even be able to just use the tab key on your keyboard and just tab along from one field to the other. So how you get from one place on your application to another is very key, because that's part of the navigational paradigm that helps you figure out how to test your application. Synchronization. So how do we identify synchronization? Typically through an image or through specific text or an attribute. And synchronization is really making sure that you know where you are in your test. The synchronization can be done automatically or manually. It can be set up locally for one script or globally for all scripts. And synchronization can either be static or dynamic. So if it's static, it would mean that you would add, let's say, a 5-second wait from when you clicked on the login screen to when your main window comes up. Now, what if your application only takes 2 seconds to come up? You've just wasted 3 seconds waiting for the application to come up. Now, that might not mean a lot, for one test, but what if it's 10 or 50 or 100 tests? All of a sudden, you've added all this unnecessary wait time that is really not valuable, and it makes your automated scripts run longer. To solve that, we use what we call dynamic waits. So we wait for a particular attribute. We might wait for a particular window to come up. We might wait for a field to be enabled, etc. And finally, validation. Validation is really making sure that the application is doing what we expect it to do. And typically we validate text so that when we enter an order for some books on Amazon, and we look at the total, and we have a coupon that we apply. We want to make sure that that coupon is applied and that the amount in the total field is actually what we expect. And the validation can also be on attributes. It can be whether or not a particular field is enabled or isn't focused, or is any number of attributes that fields and controls can have. Now, one question that people tend to ask often is, well, what's really the difference between synchronization and validation? Aren't they really about the same? And I've attempted to answer that by stating that synchronization ensures that you've arrived at the correct place so that validation can confirm correct application behavior. So really the synchronization part of the equation is all about making sure you know where you are in the application, that the script hasn't run ahead, that it's basically catching up to the application. And the thing that a lot of people coming from a manual test environment don't realize is that they're already doing synchronization as a manual tester, because you just wait for that to happen before you keep on going. Unfortunately, the tools aren't so smart, so you need to actually have that behavior codified, because if you don't, those scripts will quite often and quite regularly get out of sync, and then you're really back to where you started. So synchronization is a very important part of defining what needs to be in a framework prior to the validation step. Now, when we talk about objects and controls, each object has different attributes, but they also share certain attributes. And conversely, some attributes are only specific to certain objects. So when we talk about objects, what are we really talking about? We're talking about the button that you press. We're talking about the input field where you enter information, be it alpha or numeric or a combination. We're talking about things that you select, or links that you click on, or text areas that you click on, anything that basically will elicit a response from the application. Now, when we talk about object attributes, there's a number of different object attributes, but the most common ones are things like the autofocus, whether or not autofocus is set to that field, meaning that the cursor or the I-beam is flashing on that field, whether that object is disabled or not. You'll notice that sometimes, depending on authentication or user rights for a system, you may log into a particular system and certain fields are grayed out because you don't have access to those. So that checking that that is grayed out or disabled would be a good check to make sure that that functionality is not enabled for certain accounts, but is enabled for, let's say, an administrator account. We can also get attributes like the height and the width of that object, and even the location of that object on the screen. The name of the object, typically objects do have names if developers make sure that they do. Otherwise, it can be a randomly generated number that's assigned to that object at the runtime. And whether or not that object is required for input or not is something that we can check for. And the last two are the type of object. Is it a button or is it a radio button? Is it an edit field or is it a drop-down list? And why is it important to know that? Because when we talk about building automated frameworks, we're talking about building generic functionality. And to know how to interact with those different objects, we need to know what objects our application has. So if we were to come up with a list of a dozen or 24 objects that are most commonly used across our applications, we could write functions for each one of them that say, okay, every time I need to interact with a radio button, I'm going to go to my function for radio buttons. Anytime I want to go to my and input something into my edit field, I'll use my edit field function. So you can actually limit the number of functions that you have to the types of controls and objects that you have, and then just reuse those functions time and time again. And the last attribute, of course, which is probably the most commonly used, is the value. What is the value? When I go ahead and interrogate my price field, what's the price in that edit field? Does it say 1,250? And if that's what's in there, that's then the correct value, and then the test has passed. So examples of functions. Well, we have object input would be how to actually do an input for a particular type of object. The validation and the interrogation. Those would be the three major functions that you want to write for the different types of objects that you have. With respect to framework support functions, a framework is more than just interacting with and interrogating the application. There's a lot of things that happen in between, even before the testing starts and after the testing starts. For instance, some applications, when you create a new order, they'll have a unique order ID. And often what you'll want to do is store the result of that new order ID, because maybe the follow-on test will be to go into that new order and make an edit on that order or do something. So you need to be able to dynamically capture values in runtime, store them somewhere, and then bring them back up for a subsequent test. And that would be a framework support function. Pre and post conditions may include setting up the right data automatically before running the test, and then clearing out certain directories with reports that were created during that run, et cetera, et cetera. And then, of course, error handling is very important. We want to have functions that make sure that if there are errors during the runtime, as much as possible, if we can anticipate what those errors are, we can try to code against them, and we can possibly have our automation framework stop that particular test and resume at the next test, so the sequence that you have isn't what automatically stops for an entire run. So, survival of the fittest. How do we actually survive in the world of automated frameworks? What do we need to do to be successful? So, the first thing is that we need to make sure that we capture transition values. That's really important to be able to do that connectivity from one script to another. If you're doing end of day cycle, end of month cycle, anything that where one test provides the input to the following test, that's very, very important. So with our strategies for automation, we, number one, have to abstract our framework. We need to make sure that the framework, as much as possible, does not contain specific information about navigational paths and other things of what our application is based on, because those things can change, and rather than change them in the code, let's change them outside of the code. Number two, let's identify the roles and the staff to do automation. As we said earlier, automation does not equal testing. So let's not have someone who's an expert in the domain but knows nothing about code. Let's not have that person be the lead on automation, because that's not their area of expertise. Let's find someone with some development experience that can take on the building of the framework, but then let's have the business user, the domain expert, the functional tester, have all those people contribute by being able to define the test cases, run them through the automation, and look at the results. But the actual development of the automation code should be done by a technical person. Now, what's the right project to start this with? Well, the right project is one that isn't too early in the development and isn't too late in the development. If it's too early in the development, chances are things are changing from release to release. Screens are changing, designs are changing, controls are changing, and automation doesn't like that. You'd have to be constantly changing what your automation is doing and what you're trying to recognize. You'd be spending a lot of time. So too early in the process does not make sense. Too late in the process doesn't make sense either. If you have an application that's a stable application that's been running now for many years, there probably aren't a lot of bugs that are found on a regular basis. So the value of spending time automating something that might be maybe even close to sunset years where it might be replaced is not so good. You want something that's kind of square in the middle that will allow you to really provide some benefit, where periodic releases are coming out, where updates are being made, but where you also need to validate that the functionality continues to work. And lastly, you need to really focus on the data. Test automation is all about the data. Unfortunately, with many manual testing efforts, the data often is in someone's head. And even though this test script might talk to what we're trying to do, unless the data is actually defined, the automation is just not going to work. So tests should have a singular focus in terms of what you do. Objects should have corresponding functions that are built to support them. The data for the 4 keywords that I asked you to remember, input, navigation, synchronization, and validation should be defined. So your input data, of course, is what you enter, but even navigation, how do you get from point A to point B? You may need to click on a link. There may be a tab that you use, a window tab. All those things need to be defined in the test case so that there's no question as to how you get from one point to the other point in your application. Avoid using application logic in a framework. This is something that I've always felt very strongly about, and I was actually very pleased to see a post on the Google testing blog recently that talked exactly about this. And the basic idea here is that the application you're testing has logic that's built in. That's what the developer has done to make the application work and do its calculations. As a tester, you really want to avoid trying to replicate that logic in your test environment. Obviously, you need to come up with the results for the data to know what the correct results are, but do not add logic into your test code because you actually increase the chance of error in your calculations in doing that. So it's better to keep logic out and just the results and values that you're testing in the framework or in the data that's driving the framework. Abstraction is a key element to make sure that you have reusable components. Abstraction is also what allows multiple people in different roles, different skills to use the automation because now you've developed something that's very generic and reusable. And abstraction, believe it or not, will also help you develop test cases in advance. Why? Because if all of the information that you need to codify to run the test is done outside of the automation environment, you no longer have the excuse of not having the application there to be able to write your test cases or to be able to write your automation. If the developer already gives you a list of a dozen or 24 different types of controls that they use, you can already start writing your functions for that. And then if you already have a general sense of the application flow, you can already start developing your test cases. So there is a lot of work that can go on before the application actually hits your test environment. With abstraction, we lower our maintenance requirements, and with abstraction, we end up having an environment that's adaptable to future technology. So, how do we bring this all together? Well, first of all, there are different framework approaches for different folks, and the development of the framework is possible. I can tell you that firsthand, having done this many times. Don't try to develop something that's beyond your technical grasp or that of your team. So I did explain 3 types of approaches to framework development. And what's important is to select one that makes the most sense for what you can do and support and work with. Additionally, there are external resources, essentially people that you can bring on board to help you figure out how to start this process and then take it over from there. That could save you some time and some missteps, and you avoid some of the problems that the others have gone through. And the final thing that I would say is, since framework development is something that typically will get a lot of visibility, start with a pilot. And what I mean by that is, instead of trying to develop an automated framework against an entire application, do it for a small part of the application. Show that early success, get the buy-in from everybody, and then you can apply that same concept of what you learned within that application and then across to other applications. So that summarizes the talk on framework development and all the things that you need to be thinking about. I hope you found this very valuable, and now we move on to the Q&A section.
Andrew, I want to thank you for really an outstanding job. You've really built a compelling case for framework architecture for test automation. Really some great, information. We do, so if anybody has any questions, go ahead and send those through. We have a couple of questions already. And one of them, I know you talked about which framework approach, or several framework approaches. I think there are 4 of them. Is there one that you recommend, and why would you recommend that one?
Well, like I just said as I was closing, the recommendation is really based on the skill level and the support in any given organization, and that will vary. Some organizations, the testers are extremely technical and have coding background. In other cases, the testers are extremely domain knowledgeable, but aren't necessarily technical. From a consulting standpoint, as a consulting company, we tend to focus mostly on the process-driven model, because we find that it gives us the most bang for the buck, and it requires less maintenance. And when we're doing work for hire, we want to make sure that the customer is actually able to take something and go with it. But I would say that's really all based on the technical skill of the testers or the developers who will be involved in creating that first iteration of the automation framework and then maintaining that automation.
Okay, good. Here's another question, a specific question, I think. It says, could you explain how to create test data? Like, for example, that which involves names. Each time a new name should be used in the test case. So how do you create test data, for example, involving names, when each time a new name should be used in the test case?
Right. So that's also kind of an automation task. There's a number of different tools available. Some of them are even free tools that allow you to generate hundreds, if not thousands or tens of thousands of data sets based on particular parameters and criteria. So there are test data generation tools, and if that's the problem that you're having in defining multiple sets of data, I would recommend just searching for test data generation tools, and you can evaluate different ones depending on how specific the data needs to be in your case. Some of those tools will be more able to customize the random creation of data that meets your particular requirement, whereas others might just give you general in combinations and permutations, but the text may be like unreadable, but it will at least be unique. So that's what I would recommend.
Okay, great. A couple of more questions. How do you rate the performance speed for each of the framework types? So again, how do you rate the performance speed for each of the framework types?
Yeah, that's an interesting question. And what's important in automation, everybody knows that automation makes your scripts go faster, but what people don't realize is that when you start investing a lot of time to automate tens of hundreds of thousands of scripts, all of a sudden, you know, your execution times could be into the multiple hours or longer, and you want to make sure that all the tests get automated. So you want to make sure that your environment and your framework is as efficient as possible. Now, I would say that from the order of data-driven to keyword-driven to process-driven, I would probably venture to guess that the data-driven is the fastest, only because it's the most directly connected to the actual script itself. There's very little processing that's being done by the framework in order to run the test. So I would say that in the order that I presented them, data-driven, keyword-driven, process-driven, in terms of speed of execution, that would be the order. And the reason why I say that, as much as I say that the data-driven is fast, the process-driven script, if you recall in the presentation, it had the column that had the object name, right? Whether it's the name field or the OK button, but it didn't tell you what type of object it was. It only told you the name of the object. So what that means is that your process-driven script needs to get that name and look for that name in a GUI map or object repository and figure out, okay, what kind of object are we talking about here? Oh, okay, that's an input field. Now let's go to my input, method to do the input. So all of that takes, potentially milliseconds to do, but it is adding some additional time from the time that you would have otherwise done if you just had a straight data-driven test.
Yeah, that makes sense. That makes sense. Another question, what is the main difference of flexibility, adaptability, and extensibility in regards to test frameworks? So what is the main difference between flexibility, adaptability, and extensibility with regard to test frameworks?
Right. So adaptability is talking about being able to adapt to your application. Whatever your application is, whatever your application environment is, being able to adapt to that environment and making sure that you are able to touch all of the controls, that you're able to interact with them, populate them, or interrogate them and pull information out of them. Extensibility is saying when we have a new type of control that we now introduce, a grid, a calendar widget, something else, when we introduce that into our application, how easily adaptable is our automated framework so that we can bring that into the framework and have a function that will then interact with that calendar widget in the same way that we have a function that interacts with the edit field. Flexibility is kind of an overarching term that basically says we need an environment that's flexible essentially to all of our needs of what we're trying to do, not something that's rigid and that only kind of does one function. And I think that pretty much covers those.
No, I think so. So another question here, and I think it's a good one. What does an automation tester expect from the manual testers in a QA team? So again, what does an automation tester expect from the manual testers in a QA team?
Right. It's basically 4 letters, INSV. You need to know what the inputs are for that application. You need to know how to navigate through that application. You need to know where to synchronize, what parts of the application may slow down or may require synchronization. And finally, you need to know what the validation criteria is. Now, the most important that you can probably get from the tester is the input and the validation. If you know what drives the application and if you know how to validate the results, you pretty much have most of it. The navigating through the application, that's usually something that you probably already know, or that there's some documentation about the application, how the application works. If you needed to do a report, here are the steps to do the report. If you need to put a custom order, here's how you would do that. And then the synchronization is something that, even if it's not defined up front, as you start running your automated tests, you can always realize places where the automation is getting hung up, is either being delayed or is moving forward too quickly, and you can actually go ahead and add synchronization points into that script to make sure that the script is in line with and synchronized with the application.
Perfect. So I want to kind of conclude here just with a couple of quick notes. One, again, thank you, Andrew, and an outstanding job on what is really a very difficult subject, enough to the point that it is part of the advanced certification. But you can see the great value that it would bring both to your career, having that certification, as well as the value that it would bring to your team. It doesn't seem like a hard sell to your boss to get some support in terms of preparing for and taking that exam because of the value that it would bring back immediately to the company. You can find more information about that at the ASTQB website at ASTQB.org. I also want to really emphasize the fact that the type of information that you heard here from Andrew and the types of questions that you can ask as part of that interaction are really what the ASTQB Summit are all about. It takes place this September 15th. It's a Friday in beautiful sunny Southern California, Irvine, California, right there on the campus. And this whole summit is really, it's just one day, but you'll immediately find ways to reduce your stress in terms of testing. You'll find ways to test more quickly. And really, you'll build, I think, what's a pretty neat network of fellow testers, because there are other testers who will be there who understand the value of ASTQB and ASTQB certification. And you get to meet testing experts like Andrew. And that's just a great opportunity to get in and get out very quickly. We hope you can join us. You can also learn more about that at the ASTQB website at astqb.org. With that, we'll conclude this webinar, and I want to again thank Andrew and all of you for participating. We look forward to seeing you or hearing you on the future webinars as well. I should also finally note that this webinar is being recorded, and we will post that recording on the ASTQB website and send a link to that via email that will go out broadly. So don't worry, this is being recorded. I know there was a lot of information that we covered, great information, and it will be available. As well, you can follow up with Andrew if you have some specific questions. So thank you once again, and we look forward to having you join us not only at a future webinar, but also at the ASTQB Summit later this year.